Problem number 71, we've got these two rational expressions and they're to be subtracted. We know what to do here. We're going to start by rewriting each original fraction with factored denominators. So let's start. So we're going to have, well, let's start here. We're going to have 2q plus 1 over, now this is going to go as 3q and q, and I think I'm going to try a 4 and a 2 to get that 8, and actually I did it on paper, so I know that it works. The 8 is negative, so these two numbers have opposite signs. That middle sign, that plus sign, I'm going to put it with the bigger product. And the way I wrote mine, inner product is 4q, outer product is 6q. That's bigger, so I'm going to put the plus sign here. Right? Plus 6 minus 4 is plus 2. And then minus, we're going to get a 4q plus 3 over, and I think that 4q, I'm going to go with a 4q and a q, and then I'm going to go with 4q, let's go with a 5 and a 2, and I'm going to make this a minus 5 and a plus 2. And how do I know? Because I did it on paper before. So now we've got the LCD. The LCD here is the 3q minus 4, the q plus 2, and the 4q minus 5. Okay, so let's see what we can do with this. Let's draw a big fraction bar and write LCD in the denominator. Now, let's come back to each one of these fractions and make any adjustments that we have to the numerators. So we've got this 2q plus 2. Now, look at the original denominator compared to the new. What's missing? Here's the 3q minus 4. Here's the q plus 2. What's missing up here is this 4q minus 5. So you can see we've multiplied the original denominator, right? There's the original. We multiplied that by 4q minus 5. So we need to multiply the numerator by 4q minus 5. So let's do that. So we'll get 4q. You know what? I don't want to do it that way. What I want to do is this. I want to start with the 2q plus 1, and then I'm going to multiply that by the 4q minus 5. The order doesn't matter. It would have been fine. Minus. Now what about this 4q plus 3? Well, that 4q plus 3 right here, compare the original denominator to the new one. There's the 4q minus 5. Here's the q plus 2. What's missing is the 3q minus 4. So we've multiplied this denominator by 3q minus 4. Let's multiply the numerator by 3q minus 4. So we'll have 3q minus 4. Now, let's multiply these numerators out, and then we'll combine like terms. So when we multiply here, let's do that. We're going to get 2q times 4q is 8q squared, and then the outer product and inner product. Here's negative 10q plus 4q, negative 6q, and then the last is a negative 5 minus. Now, we know these minus signs just cause us an extra step. So what I'm going to have to do down here, minus, I'm going to multiply this out, put it all in parentheses, and then in the next step, I'll take the minus sign through. So we're going to get minus all of this. So we're going to get minus. Now, let's multiply these together. So we'll get 4q times 3q is 12q squared. And then the outer product is negative 16q and then 9q. Negative 16 plus 9. We'll get a negative, well, what happened here? Negative 7q, and last in the last will give us a negative 12. And this is all over our LCD. Now, let's remove these parentheses here. So let's take that minus sign through. So we are now going to get 8q squared minus 6q minus 5, and then minus 12q squared plus 7q plus 12. all over, I'm still going to write LCD because I can still do something up there on the top. Now let's combine terms here. So we'll get, like terms, we'll get 8q squared minus 12q squared is negative 4q squared. Then we'll get minus 6q plus 7q is plus q. And then minus 5 plus 12, that's a plus 7, all over the LCD. Now, I don't think this is going to factor. I don't think this top is going to factor. So I'm just going to write the LCD, which we have, right over here, right down here, we got it circled. So we'll get 3q minus 4, q plus 2, 4q minus 5. And remember, the order here in the denominator doesn't matter. Now this problem's a little bit different than the ones we've been looking at. First of all, you can see it's much less complicated. You know what? Let's take a look at something like this. What if you have, this is just an aside now, but this will show us how to do these quickly and easily, I think. What if we have a number like 3 2/5? Now, you can change this. You know how to change this to an improper fraction, right? We've got a mixed number. Change it to an improper fraction. Here's how I learned to do this. I take the bottom times the whole part, getting 15, add in the top, that gives me a 17, and I put it all over this. So this thing here, I'm going to write like this. 5 times 3 plus 2 all over that 5, so I get 17 over 5. So what I did here is that I took this mixed number, I multiplied the bottom and the whole part, added in the top, and put it all over this denominator. Now, really what's going on here is this number is really this number, 3 plus 2/5. It's just that instead of writing this, we compact it a little bit more and write this. Now, we have this form right here, a whole part and a fraction. That's what we have up here. I got a whole part and a fraction. So here's what we do, right? Let's just go down here and look at what we did. We take the bottom times the whole part, add in the top. Let's do that up here. The bottom times the whole part, so we're going to get 5 times x plus 7. 5 times the whole part, add in the top. So our top up here is this 5. So bottom times the whole part, add in the top. So plus 5, and you put it all over that denominator. There we go. Now all we have to do is simplify it. So we'll get 5x plus 35 plus 5 all over x plus 7. This will give us, I'll do it up here at the top, 5x plus 40 over x plus 7. It looks like we can factor here, right? So I'll take a 5 out. We'll be left with x plus 8 over x plus 7. I suppose we could have left it like this, but I just like things in factored form.